Good evening, algebra students, and welcome to another lesson. We are in chapter 8, section 2, and we are now multiplying a monomial to a polynomial. So what I'd like for you to be able to do by the end of this lesson is to multiply and divide a polynomial by a monomial by applying properties of exponents. So far we've only been adding and subtracting. Now we're including multiplication and division. So in order to multiply a monomial to a polynomial, you're going to need to use the distributive property. So I'm going to highlight that because that's pretty important. We're going to use the distributive property. And what I want you to remember is when you are multiplying powers with a common base, that means you add the exponents. Only when multiplying. You do not do this with adding, subtracting, or dividing. When multiplying, you add. Okay, particularly the exponents. So we're just going to do some of the distributive property next, and you're going to see that in action. So notice in example 1, I have 3x squared, and it's getting multiplied to each of these individual terms. So 3x squared is getting multiplied to 9x to the 4th, multiplied to negative 2x to the 3rd, and multiplied by that positive 7. When I multiply a monomial to a polynomial, I multiply this by each term in the parentheses. I multiply coefficients, I add exponents. So 3 times 9 is 27. X to the 2nd times x to the 4th is x to the 6th. Notice I took 2 plus 4 to get me x to the 6th. I did that because I'm multiplying. Do it again. So now I have 3x to the 2nd times negative 2x to the 3rd. So I'm going to have negative 6 because 3 times negative 2 is negative 6. X to the 2nd times x to the 3rd is x to the 5th. And then I have plus 3x squared times 7. 3 times 7 is 21. And then I still have that x squared. And there's my answer. All right, continuing on with example A. I am still just distributing this across the parentheses. So what is 5n times 3n cubed? Well, I multiply the coefficients like normal. So 5 times 3 is 15. Then I'm asking myself, what is n times n to the 3rd? If you need to remind yourself that there's an invisible 1 on that n, you can. So n times n to the 3rd is n to the 4th. Then I have 5 times negative n squared. So 5 times that invisible negative 1 is negative 5. N to the 1st times n squared is n to the 3rd. Let's do our third term now. So 5n times 8 is going to be plus 40n. I can't continue to simplify because I'm not able to add or subtract these because they're not like terms. So let's go on to example B now. This time I'm distributing a negative, so be mindful of that. I have negative 8y to the 3rd times 7y to the 2nd. Well, first you need to take negative 8 times 7, and that is going to get us negative 56. Then I take y cubed times y squared, which is y to the 5th. When I multiply two terms with a common base that have exponents, I add the exponents. Okay, now I have negative 8 multiplied by negative 4, and that is going to get me positive 32 because a negative times a negative is equal to a positive. Now when I take y cubed times y, remember there's that invisible 1, y cubed times y is y to the 4th. And finally, I have negative 8 times negative 8y cubed times negative 1, which is just going to be positive 8y cubed. And there's my solution for that one. This is just the distributive property. That's all we're doing here. The big difference is you have to remember how to apply your properties of exponents, which is what we covered in chapter 7. Okay, in this next example, I have 2v, and I'm going to send it and distribute it to each of these terms. So 2v times 5v squared. 2 times 5 is 10. V times v squared is v to the third. 2v times 5b, 2 times 5 is 10. V times v is v squared. I'm making it v squared because it's v multiplied by v. Finally, I have 2v times negative 2, which is going to be minus 4v. That's my final solution to example C. And finally, on example D, I'm distributing a 4b squared across this whole set of parentheses. Remember, you have to extend it across the whole expression, otherwise you won't have completely multiplied the two terms or the two expressions together. So 4b squared times 4b squared. This is not plus, it's getting timesed. So I'm taking 4 times 4, which is 16, b squared times b squared, which is b to the fourth. Now I'm taking 4b squared times 4b. So you multiply your coefficients, 4 and 4, which gets me positive 16. And then b squared times b is b to the third. I got b to the third because 2 plus that invisible 1 gets me that 3. Finally, 4b squared times 1, that's easy. That's just 4b squared because we know anything multiplied by 1 is just that other expression. So one more time, you're going to use the distributive property, and when multiplying only, you add the exponents. What happens if we do that in reverse? So we're also able to divide polynomials by monomials, and I'm going to show you that now. So remember, when dividing with a common base, that means you subtract the exponents. You're going to divide coefficients like regular numbers, and I'm going to go ahead and say this just because if I don't, you'll probably forget, because I know that I would forget too. So no negative exponents. We cannot have negative exponents in our final answer, so we're going to make sure we're always writing these mathematically correct. Now in this example, in all of our examples, I have a polynomial divided by, because that's what a fraction bar means division, by a monomial. An easy way to think about this is to divide it into 3 division problems. So I'm going to rewrite this as 25x squared over 5x squared plus 5x to the fourth over 5x squared minus 10x to the third over 5x squared. So notice, I just divided my 3 terms into 3 individual fractions, and then I just put what they're being divided by on the bottom of each of those fractions. And now we can more easily kind of separate these out. So I'm dividing the numbers like regular. So what is 25 divided by 5? That's 20. What is, oh, that's not x squared, that's x to the 5th, my apologies. What is x to the 5th divided by x squared? Well, I subtract the exponents, so that is going to be x to the 3rd. Now I'm doing my next one. So 5 divided by 5 is plus 5, or positive 1. And then x to the 4th divided by x squared, well, I subtract exponents, so that's going to be x squared. Finally, I'm going to say minus, and this is going to be 10 divided by 5, which is 2. And x cubed divided by x squared, which is just x left over. And there's my solution. So you are dividing like regular the coefficients, and the coefficients are these numbers in front of the terms, and you are subtracting exponents when you divide. So only when you divide should you do that. I'm going to say when dividing powers, I'm going to circle those key words, because you don't do this if you're adding and subtracting, and you don't do this if you're multiplying, only when dividing. So let's look at these next examples here. In example A, I'm going to spread this out again, saying 27x cubed divided by 3x, 15x squared divided by 3x, minus 12x divided by 3x. So we can see each individual division problem. So I have 27x cubed over 3x plus 15x squared over 3x minus 12x over 3x. Now let's divide. So 27 divided by 3 is 9, and x cubed divided by x. If I need to put that invisible one, I can. So now subtract your exponents because we're dividing. That's going to be 9x squared. 15 divided by 3 is 5. X squared over x reduces to x. And finally, I have a minus sign because of this minus sign right here. 12 divided by 3 is 4. And x over x totally cancels out, so I don't have an x in that term, and this is what I'm left with. In example B, we're going to have a little bit of a messier answer, but that is okay. I'm still going to divide my 3 terms out and put them over the denominator so I can see my individual division problems. So I have 20x to the 4th over 4x to the 3rd plus 14x to the 3rd over 4x to the 3rd minus 10x squared over 4x to the 3rd. Okay. We are now going to divide all of the coefficients, and we're going to subtract the exponents. So 20 divided by 4 is 5. And then x to the 4th divided by x to the 3rd, well, I subtract the exponents, getting me just x to the 1st. Looking at my next division portion, or this next term, I have 14 divided by 4. That is not going to get me a pretty number. Instead, I'm going to leave this as a fraction. So 14 over 4 reduces to 7 over 2 because both of them have a factor of 2 in them. Then I have x cubed over x cubed. Well, those just totally cancel, so I don't have any x's in the middle term. And then I have minus. Now, this one's going to be a little messy too. 10 over 4 does not reduce to a perfect pretty number. So I am going to need to just reduce it. 10 over 4 reduces to 5 over 2. They both had a factor of 2 in them. Now I have x squared over x cubed, but notice how the larger exponent's in the bottom of the fraction. So wherever that larger number is or wherever that larger exponent is where your final x value is going to end up being. So I'm going to have x to the 1st in the denominator. So that one was a little funky for us. Now we have an expression with multiple variables. First step is to just write it out as 3 division problems because that makes it a little more manageable so we don't miss anything. Okay, so I'm going to rewrite that. I have 4x to the 5th y squared over 2x squared y plus 5x to the 4th y over 2x squared y minus 10x cubed over 2x squared y. Notice that 2x squared y was in the bottom of each of my fractions because it's on the bottom of this whole fraction in my example. So now it's time for me to divide each individual expression. Remember, I have to only divide common bases with common bases. So 4 divided by 2 is 2. X to the 5th over x to the 2nd. I'm subtracting the exponents on the x's. So 5 minus 2 is 3. So that's going to be x to the 3rd. Then I have y squared over y. There's an invisible one there. So when I'm dividing, I subtract exponents. So that's just going to be y. Now I'm moving on to my next term. I have plus and 5 over 2. That's not going to reduce. So I have 5 halves so far, and then I have x to the 4th over x to the 2nd. Well, when I subtract my exponents, because I'm dividing, I'm going to have x squared up top. But y over y just reduces, and my y's disappear for my middle term. For my last term, I have 10 over 2, which is equal to 5. Notice how all I'm doing is dividing the regular number. I am only subtracting when it's an exponent. And then I have x cubed over x squared. Well, 3 minus 2 is x, but nothing has happened with this y yet. It's on the bottom of the fraction, and I haven't been able to move it, so I'm going to have to keep it on the bottom of my fraction here. And that's my answer to letter C. We have one more example with example D. I have 30x squared plus 24x minus 18 divided by 6x. I strongly encourage you to go ahead and write this out as 3 individual division problems or 3 individual fractions. So I have 30x squared over 6x plus 24x over 6x minus 18 over 6x. So I'm dividing the regular numbers. 30 divided by 6 is 5. X squared divided by x is just regular x. Plus 24 divided by 6 is 4. And then x over x just simply reduces to, they cancel each other out basically. And finally, I have 18 divided by 6, which is 3, but nothing has happened with this x yet, so it's going to need to stay on the bottom of my fraction and hang out there as 3 over x. So with dividing, one more reminder is that you're going to divide the coefficients like regular and you subtract the exponents when there is a common base. All right, that's all for today's notes. We'll continue practicing in this in class tomorrow. Please have a good night.